Good morning, my dear students. Again, now let me start the continuation part of compact disk read-only memory in optical storage media. The compact disk read-only memory was conceived as a storage medium for general computer data. In addition to uncompressed audio data, the further CD-ROM technology was intended to form the basis for the storage of other media. It was specified by N.V. Phillips and the Sony Corporation in the Hello Book. Now let's see that the CD-ROM tracks are divided into audio and as well as data type. So where it's going to be storing data, audio, and also it's going to be containing the compressed audio and compressed the video. Each track may contain exclusively data of one type. A CD-ROM can contain both types of tracks. In such a mixed mode disk, the data tracks are usually located at the beginning of the CD-ROM, followed by the audio tracks. Now you can see that the way how the CD-ROM was structured, was arranged. Since CD-ROM storage general computer data, they require better error correction and higher resolution random access to data units than are specified for CDDA. A CDDA has an error rate of 10 to the power of minus h and allows random access to individual tracks, and this is shows that how it's going to be using 75 blocks and so more than 14 lakhs 11,200 bits per second. So into 1 divided by 75 seconds, block seconds, which is going to divide by 1 by 8 bits by byte, which is equals to 2352 bytes will be allocating for the each frame. And it also access the random access. It allows the random access and also better for the error detection and error correction operations. This is the mode 1. This is the different types of modes are available in CD-ROM. So the first in the CD-ROM specification, it was defined with the goal of storing uncompressed CDDA data and computer data, as well as it's going to be serving as the basis for other media. This is achieved by using two CD-ROM modes. An additional mode 0, where all 2336 user data bytes are set to 0, serves to separate storage areas. So now we can. This is the CD-ROM mode 2. CD-ROM mode 2 serves as the basis for additional specification for storage of other media. This is in the block, so we can see that 2352 total bytes. CD-ROM average access time. This is the synchronization time, seek time, and rotation delay. Synchronization time occurs because the internal clock frequency must be adjusted to the exactly in the phase with the CD signal. Here delays are in the range of millisecond. Due to the constant linear velocity playback of a CD, the rotational velocity at single speed is about 530 revolutions per second on the inside, but only about 2000 revolutions per second on the outside. Rotation delay describes the time it takes to find the desired structure within a maximum of one rotation and to correctly set the rotation speed. Depending on the device, this time can be about 300 milliseconds. For a CD-ROM device with a real 40 time data transfer rate and about 9,000 revolutions per minute. The maximum rotation delay is about 6.3 milliseconds. The seek time refers to the adjustment to the exact radius whereby the laser must first find the spiral track and it will be adjust itself. The seek time frequently amounts to about 100 milliseconds. This is the rotation sector with the one rotation. So this depends upon the disk speed. So around it will be going to be containing 300 millisecond. This is the average access time of data. And this is the logical file format of CD-ROM. So it was recognized early on that specification of what we studied in the mode 1 blocks as equivalent to the other data carriers sectors. It was not by itself sufficient to define a compatible data carrier. Since the logical file format and directory were missing, the ISO 9660 standard defines a directory tree which includes information about all files. In addition, there is a table that lists all the directories in a compressed form. This is so-called path table allows direct access to files at any level. The table is loaded into the computer memory when a CD is mounted. Because a CD-ROM cannot be changed because it will be in the read only. This method can be performed statically in an efficient fashion. And however, so most implementation use the actual directory tree. And here you can see that the way how they're going to be the small trees, which is going to be containing a primary information about the descriptor and as well as the root directory, which indication is very simple. The way, the way and how the data is located on the surface of the series. And also it will be more useful to understand different access time, individual data, how it was stored on the surface of the CD. So thank you.